we're working on problem number 2. According to the Bureau of Labor Statistics, the average weekly pay for a U.S. production worker was $441.84 in 1998. Assume that the available data indicate that the wages are normally distributed with a standard deviation of 90. And part A, what is the probability that a worker earns between 400 and 500? Again, we're working with a normal distribution. So I'm going to use the normal probability density function. The center here is 441.84, and the standard deviation is 90. And I want the probability that x is between 400 and 500. So we're talking about somewhere in this interval here, in the middle, almost in the middle. Well, the probability of being in an interval is the area under the density function over the interval. The density function is designed so that calculating this area calculates your probability. That area is actually proportional to the amount in each one, and we know in each part of the interval, and we know that in a mound-shaped distribution, the majority of the values are centered around the average, and the further you move away, the fewer there are. So the density function is set up so that the area is proportional to those percentages, and all we have to do is to calculate the area. Now, to do that, I'm going to need the table, and I'm going to have to calculate the z-score of the 400 and calculate the z-score of the 500. So, let's see, z of 400 be 400 minus the 441.84 divided by the 90. And the z-score of the 500 would be 500 minus 441.84 divided by 90. The z-score for the 400 is a negative 0.46, and the z-score for the 500 is 0.65. Now, let's see. If I look up a negative 0.46, I'm going to get the area down. Remember, the table always reads down from the z-score. So if I look up the negative 0.46, I'm going to get this red shaded area from the table. If I look up the 0.65, that's the z-score of the 500, I'm going to get the area looking down all the way from the 500. It's the blue shaded area that I want. That's the area under the density function above the interval. So whatever area I get for the 0.65, if I subtract the area I got from the negative 0.46, I should be able to get the blue. So in 0.65, if I look up 0.65, I get 0.7422. So the area, that green shaded region, is 0.7422. If I look up the negative 0.46, I'm going to get a 0.3228. And what I want to do to get the blue area that I want, I'm going to subtract those two. And subtracting those two, I get 0.4194, or approximately 42% earn between $400 and $500. So that is part A. Okay, for part B, again I have the same distribution. centered at 441.84, standard deviation of 90, and I want for a randomly selected production worker, what is the probability the worker earns less than $250 per week? So 250, and it's less than 250. So the probability that X is less than 250. Again, I need the area under the density function above the interval. In this case, that's pretty easy. All I have to do is get a z-score of 250, or for 250. I'll subtract the 441.84 and divide by the 90, and I get a negative 2.13. Looking up in the table, the negative 2.13, that's with the negatives go down to negative 2.1 row and over to 0.03 column. I get 0.0166, 0.0166. Now, the area that the table gives me in this problem is exactly the area I wanted. So there is nothing to do other than just to go ahead and answer the question. The probability that X is less than 250 is the probability that Z is less than negative 2.13, which is 0.0166, or 1.7% earn less than $250. Again, in this case, the z-score of negative 2.13 gives me the area I wanted. So I don't have to subtract from one or take one table value and subtract from the other. A lot of these problems are driven by drawing a good picture and then looking at the picture and matching it to what the table is doing to figure out how you can get what you want. So there's a lot of geometry. You want to think of it as drawing a good picture and letting the picture tell you what you need to do. Okay, Part C. Part C says 20% of wage earners make less than what weekly amount? Okay, well this is this other problem. This is the turnaround type of problem where it's actually giving you a percentage or a probability, and you're asked to find an interval value. So we're still working with the same problem. So the distribution is normal. And in this case, 20%. The area under the curve is given. And what we're trying to do is to find the X value. The average, again, is 441.84. Standard deviation is 90. Now, again, like problem number 1 example, we worked a kind of problem like this, only the percentage we were given was on the upper end. It's using the z-score formula. That relates all the values in these problems. But what I'm going to need is I'm going to need a z-score for X to be able to solve for X. So let's look up the z-score for X. How do we do that? In this case, it's looking up the 0.2 as a probability. And the z-score for X is going to be negative since X is to the left of the center. So I'm going to try to get as close to 0.2 in the table as I can and figure out what the row and column are. The closest I can get is 0.2005, and that's on the table with the negatives. It's in row negative 0.8 and under column 0.04. So the z-score for X is going to be a negative 0.85. Now in my z-score formula then, I'll have a negative 0.84 is equal to x. Well, we're trying to figure out, subtract the 441.84 divided by 90. Now if I multiply both sides by 90 and I add 441.84, I'm going to get x equals $366.24. $366.24. So 20% of the workers here are making less than $366.24. 20% of these earners make less than $366.24. Okay, between these two examples, 1 and 2, I think I've covered the mechanics of how to solve probability problems with this density function and table. And again, these two problems are well representative of the kind of problems that are in that section. So look at these well. Let me know what you think of the lecture scribe and if it worked. Before the next exam, I will try to have additional help sessions. So keep me informed. Thank you.